Imagine a world where you don't just print documents, you print objects. From toys to tools, from medical implants to airplane parts, 3D printing, or additive manufacturing, has transformed the way we make things. Today, we'll explore its fascinating history, from its invention in the 1980s to the revolutionary printers available in 2025, showing how this technology went from exclusive industrial labs to almost anyone's desktop. 3D printing started in the 1980s. The first technology, stereolithography, was developed by Charles Hull in 1983. It used ultraviolet lasers to solidify liquid resin, building objects layer by layer. This invention became the basis for the company 3D Systems, which commercialized the first stereolithography machines later in the decade. In parallel, other approaches were emerging. In 1986, Carl Deckard at the University of Texas developed selective laser sintering, SLS, a process that used a laser to fuse powdered material into solid structures. SLS made it possible to create stronger, more durable parts and opened the door to printing with a variety of materials beyond resin. The late 1980s also saw the development of fused deposition modeling, FDM, by Scott Crump, who later co-founded Stratasys in 1989. FDM worked by extruding melted thermoplastic filament through a nozzle, depositing it layer by layer. This method was simpler and more affordable compared to resin or powder-based systems, setting the stage for the desktop printers that would appear much later. By the 1990s, these technologies were moving from research labs into industry. Companies such as 3D Systems and Stratasys began selling commercial machines to manufacturers, who primarily used them for rapid prototyping. For the first time, engineers could test form and fit of designs within days rather than weeks, reducing development time and costs. Though the machines were expensive and limited in capability, the 1990s marked the period when 3D printing became a recognized tool in product development across sectors like automotive and aerospace. In the 2000s, 3D printing started expanding beyond large corporations. Machines became slightly more affordable, $20,000 to $50,000, and universities and small businesses started experimenting with them. In 2005, the RepRap project introduced the idea of a self-replicating 3D printer. Suddenly, hobbyists could imagine owning a printer for under $5,000. Materials expanded beyond plastics, including metals, ceramics, and even food items. While still rare, the maker movement began to take shape, inspiring people to experiment and share designs online. By the late 2000s, online communities such as Thingiverse, founded in 2008, gave hobbyists a platform to share digital models freely. This helped spread awareness and encourage collaboration among engineers, artists, and tinkerers worldwide. At the same time, industries like aerospace and healthcare began to adopt 3D printing for more specialized applications, such as lightweight aircraft components and custom medical implants. Although costs remained high for most individuals, the decade established 3D printing as more than just a prototyping tool. It was becoming a creative medium, a research platform. By the 2000s, desktop 3D printers were increasingly affordable, typically $500 to $2,500. Materials improved. PLA, ABS, flexible filaments, and composites became common. Makerspaces, schools, and libraries offered access, allowing students and hobbyists to create everything from gadgets to artistic sculptures. The decade saw viral growth on social media, showcasing 3D printed toys, tools, and prototypes. Filament costs dropped to $20 to $30 per kilogram, making experimentation practical. Public adoption grew steadily, laying the foundation for a generation of creators familiar with 3D printing. At the same time, industrial applications accelerated. Metal additive manufacturing matured, enabling aerospace and automotive companies to produce lightweight, high-strength components that could not be manufactured through traditional methods. In medicine, 3D printing advanced toward patient-specific implants, prosthetics, and even early bioprinting research for tissues. Crowdfunding platforms such as Kickstarter played a major role in popularizing consumer printers, helping startups launch affordable models that appealed to hobbyists worldwide. Open-source firmware and slicer software also evolved rapidly, creating a more user-friendly experience. By the end of the 2010s, 3D printing had become both a practical tool and a cultural movement. Whether in classrooms, research labs, or garages, it was no longer a futuristic idea. It was part of everyday innovation. By the mid-2020s, 3D printing had moved from hobbyist tools to a core part of manufacturing, healthcare, education, and daily life. Affordable printers under $200 and advanced industrial machines enabled everything from concrete houses to lightweight aerospace parts and custom prosthetics. The COVID-19 pandemic highlighted its flexibility, while sustainability grew with recycled and bio-based materials. In 2025, the technology is smarter and faster than ever. Consumer printers under $150 now feature high precision, larger build volumes, and AI-assisted design. Industrial machines for metals, ceramics, and composites are cheaper, energy efficient, and accessible to small businesses. Materials range from biodegradable PLA to carbon fiber, while bioprinting and even food printing advance in labs. Public access has expanded through makerspaces and on-demand printing services, keeping costs low for hobbyists and professionals alike. 3D printing in 2025 shows just how far the technology has come. Smarter, faster, and more accessible than ever, it reduces waste through on-demand production, enables deep customization from prosthetics to household items, and accelerates innovation with AI-assisted design and rapid prototyping. Looking ahead, 3D printing is set to further reshape manufacturing, education, and healthcare. From a laser in a lab in the 1980s to desktop printers in homes today, each layer printed reflects decades of invention, creativity, and human curiosity. Whether you're a hobbyist, student, or engineer, 3D printing now turns imagination into physical reality every day.